Thank you, Chair John. Good afternoon, everyone. Following the excellent presentation of Dr. Hu, I'm going to also talk about the environmental impact assessment in Taiwan. However, unlike the description of Dr. Hu, I think the environmental impact assessment is still at a very early stage in Taiwan. So I don't think I'm going to inform, but instead I'm going to invite comments and advice from the audience. Okay, so first of all, I'm going to introduce the background, why we consider the environmental impact assessment of the CCS. And secondly, I'm going to present, because we already collect information from the public, how they are concerned about the CCS. And then I'm going to present a little bit about the preliminary CCS strategic environmental assessment in Taiwan, and also the methodologies we are thinking of using for SEA. And finally, a little bit suggestions for future work. Because the CCS policies are considered within the framework of sustainable energy policy. So we can see that actually in Taiwan, we are thinking about the different aspects of energy. So in that ground, we are formulating different various programs and policies associated with energy. So, for example, we have guidelines for sustainable energy policy, which was in 2008, and also we have the National Action Plan on Energy Conservation and GHG emission reduction, which was in 2010. In this National Action Plan, we included NAMA, carbon emission from the power supply, and also strategic environment assessment for energy-intensive industries. And also we had energy conservation and carbon reduction for other industries other than power industries. And also we have the National Energy Program, which are academic oriented. And also, already mentioned by Dr. Hu this morning, we have the new energy policy. We have different targets by different years ahead. Probably we can look at this figure. We have two economic development scenarios ranging from high, medium to low. So for example, if we look at the high growth scenario, the CO2 emissions estimated by business as usual will be 433 million tons by 2020. The target of CO2 reduction based on the emission of CO2 in 2005, which is 244 million tons. So we have to reduce about 190 million tons of CO2. So after implementing, beforehand, we can have an estimation of all those plans. When those plans are implemented, we can reduce the carbon by 136 million tons. Still, we have about 52 million tons of CO2 gap to reduce. So, for example, we can consider low carbon energy, the energy conservation, carbon sink, and carbon credit management. So in total, those plans will result in about 136 million tons of reduction. And probably you already noticed that the nuclear power plant is still a controversial issue. So if that nuclear power plant cannot be put into use, then the gap will be larger. So here we have about 52 million tons of CO2 gap for this reduction target. So that is why carbon capture and storage is one of the options to fill the gap. So then what is the status of the CCS in Taiwan? Actually, because we are still at the early stage of this research, so most of the resources are directed to the basic academic research. The purpose of this research is to gain more information and more knowledge. We have more understanding about the safety and economic and social issues associated with the CCS plan. At the same time, we already constructed the partnership among different governments, industry, academic, and also the public. So, in couple with the information collection, we try to develop the policies regarding CCS. And then the next step will be formulate a legal and regulatory framework. And also at the same time, we hope there to have more international cooperation. Okay, so this figure shows a little bit about the picture about the cooperation among different units, different organizations, and different stakeholders. Basically, there are two parts. One is for technological advancement. The other is for legal and strategic planning group. So here in this technological advancement group, we have from, for example, Taiwan Cement, China Steel, CPC, and also Taiwan Power Company are included in this group. And for this legal and strategic group, the purpose of this group is to formulate the strategies, laws, regulations, and also have public education and communication. So basically, this group includes the concerned public authorities like EPA and the Ministry of Economic Affairs. Okay, so since 2010, Taiwan has had 40 CCS studies, but no demonstration project of carbon storage has started yet. So if we look at this, we can see that most of the research are focused on capture stage. This figure shows a little bit about the site information which can have potentially have the capacity of storage. This is actually estimated by Professor Lin, who's going to present his work later on. So we can see that in total, the optimistic estimation of the storage capacity, including terrestrial and maritime, would be 48 gigatons. Okay, so what is the major concern of the public? Because we already initiate the public communication stage. So from those communications, we collected some information about their concerns. So first of all, the pros and cons. We already know that the pros is that the CS is one of the options to fill the gap of carbon reduction. And CCS is also a very good support of intermittent renewable energy using clinical technologies. And also, of course, it will improve the carbon footprint of the products. So those are actually the merits why we should consider CCS. But also there are also cons. For example, basically, I think the public would like to place priority on energy efficiency, the management of the demand side, and also renewable energy development. So they are worried about that if we go ahead with the CCS, then we might decrease energy safety and continue the unsustainable energy supply, which relies on imported coal. So what are the concerns about the CCS development? We can talk about this from three aspects. The first, economic issues. So they are worried about the comparison, the good and bad of the cost resulting from various technologies for carbon reduction. And also, what is the financial mechanism that might be in place from governments or enterprise for the research and development of CCS? And also, how real is the impact on the footprint of the products exported? And also, because in order to have more advanced understanding about CCS safety related issues, we need to have the CCS demonstration project. So how will this project be put together to meet the scale of commercialization? And also, what would be the domestic CCS niche market? And secondly, we look at the legal and regulatory issues. So regulations and guidelines to ensure the effectiveness and the safety of the CCS, and also regulations and guidelines on the size of carbon storage in terms of the area of inference and injection capacity. And also, it is possible to examine environmental impact assessment when the injection capacity is less than some amount. Okay. And also the social issues, especially with public participation and acceptance, and also information transparency. So when we look at the technology itself, we can analyze this technology from the different life cycle stages. One is capture. So at this stage, we look at the environmental impacts on land uses, water and air quality, and also regulations on the CO2 absorbance, like solvents, the health, safety, and environment issue, and also energy penalty, which already described by Dr. Koenig. And also at this stage, transportation, environmental impact evaluation, design of pipeline transportation, and also the cost, the monitoring and the verification and risk for different transportation media. Finally, for the storage, okay, those are the major concerns by the public. For example, the baseline information, because right now we are still collecting the baseline information and the estimation of carbon storage capacity and potential site. As we see from this figure estimated by Professor Lin, but that estimation is quite optimistic. And also CO2 leakage and its impact on ecological and human health, and the probability of earthquake caused by CO2 injection, and also the public perception on CO2 leakage caused by earthquake. And then risk acceptance corresponding with carbon storage, and the liability and responsibility after injection. Then I'm going to talk about the preliminary strategic environment assessment in Taiwan, which is actually the major part. I would like to invite comments and advice of. Okay, so this is a comparison between the strategic environment assessment and the project-specific environmental impact assessment. As described already by Dr. Koenig also, the strategic environment assessment is applied for policy plan and programs. But this is for specific projects. Okay? And we have different laws regulating the two activities. And also they are pursuing different purposes. For example, for SEA, we are looking at the comprehensive analysis of CCS policies in order to legitimate the application of the CCS. But for project-specific EIA, the focus is to look at the project-specific impact and also look at the opportunities to reduce the impact. So the scope. Actually, after Dr. Koenig's presentation, I would like to ask him about the qualitative presentation because most of the time, not all the time, but most of the time, only qualitative information can be collected. So probably qualitative and integrated evaluation of different CCS policy scenarios have to be presented to the public and to the government. So how can we plan optimal policies based on those qualitative information? So that's the difference between from these project-specific EIA. So for EIA, it is assessment of environmental impact as a result of choice of alternative technologies, operation, and locations. Okay, so the flow. Okay, so here is the our preliminary plan for the flow of the CCS work. The first stage is consultation with the public. And then we will go ahead to this stage, public hearing. By collecting this information, one is the statement and policy objective here, and the international conference, which is actually today. So we are going to have the information from the international conference, and then after this, we will have this first version of CCS impact assessment statement. And then after this public hearing, there will be more focused questions and problems that we will hand on to the expert committee to develop the second version of the statement. And then we'll have the final public hearing, and then we'll finalize the impact assessment statement. Okay, so what kind of projects or what kind of programs need to be subject to SEA or EIA application? So actually there are two kinds. One is direct application. So when that kind of activity is included in this obligatory list of policy plan development activities, then it has to be subject to SEA or EIA, or they are existing regulations, or it is related to environmental protection or sensitive area. Even those activities are not included in this list, then it can still be judged by competent authority based on threshold of concern. Okay. And the third way is the voluntary strategic environment assessment. So here is the substantial flow procedure of SEA. So the first one is consultation with authorities, defining policy objectives and alternatives, defining scope of evaluation, constructing the framework of environmental impact assessment report, and also formulating the evaluation plans, including indicators and methods. And then finally, we will develop the environmental impact statement, then execute action plans to monitor and reduce environmental impacts. Here, at this stage, we are still at this stage. We will, I think, recently we will start this demonstration project. So what are the objectives of CCS policies? There might be these options, or in combination with these options. One is to reduce anthropogenic carbon emission to improve air quality and abate the environmental impacts of climate change, including environmental benefits, and to meet the target of GHG reduction. The secondly is to foster indigenous technology, research and industrial cluster in Taiwan, because CCS is beneficial to reducing carbon footprints for products, as mentioned before. So here, this objective is more emphasized with social and economic development, technology research and development, and international cooperation. And also there's a third one, which is to optimize national land use plan for sustainable land management. So according to these three objectives, there might be three corresponding alternatives. For example, for the first one, we have to consider the different energy conservation scenario, renewable energies, switching fuel mix, and so on. And also for the second objective, we might have these alternatives like capture and domestic storage with larger capacity, or moderate capacity, or smaller capacity. Or the other is storage abroad, which already been announced by, I think, by the expert in this morning. And also we have alternatives for the third objective, is to consider the different land use possibilities like geothermal heat production, injection of produced water from the oil and gas industry. Okay, then the scoping phase is to, here we focus on the concerned stakeholders and authorities. Hope that they can help to determine the scope and the detail of the environmental assessment report to ensure that the SEA covers the likely significant environmental effects of the plan. And also, we want to know what kind of values and interests we want to protect. So those are the research questions associated with selecting alternatives, like location-wise, temporal issues, scenarios, data information, and experts involved. Okay, so those are the content of the environmental impact assessment report. First one is who is the responsible authority, the name and goals of the policy, the current state of the environment under the existing policy, which is the zero alternative, and then the relationship between CCS and the other environmental policies, alternatives to the policy plan and program and their impacts, and finally, the mitigation and monitoring measures. Okay, so at the evaluating phase, we look at the different stages. So probably we can read this. We look at the energy generation technologies. We look at the possible sites of carbon capture. We look at the transportation media route, and also the options for carbon storage, like geological, oceanic and mineral combination, and also competition of underground storage, okay, and also potential sites for carbon storage. Okay, so those are the considerations in this evaluation phase. So if we can look at this matrix, okay, evaluation matrix for CCS, so look at the technology aspects, economic, environmental, and social aspects, and also look at the different life cycle stage. So those are the key considerations which will be assessed in this SEA project. For example, at this capture stage, look at the technology. We'd like to consider energy consumption, capture efficiency, and so on. And look at economy, we would like to look at the capture costs, and also legal and regulatory costs, and so on. I'm going to just skip this one. So those might be too detailed. Probably we can look at the major items, like for environmental impact. What we are looking at include carrying capacity of the environment, ecosystem and landscape, human health and safety, use of land resources, water resources and uses, cultural heritage, international regulations on the environment, and also social and economic factors. Okay. So those are too detailed. Just skip this slide. Those are evaluation items for human health and safety. We look at chemical, look at hazardous waste, look at hazardous material, look at the radiation, and also I can skip this one. Look at the resources, water, look at the international regulations, Montreal Protocol, which is an ozone issue, and so on. And other are economic and social factors, like energy use, economic, infrastructure, community development, and so on. Okay, so look at the methodology. The methodology we are thinking actually quite in line with those mentioned by Dr. Koenig. Look at the life cycle assessment and also risk assessment. We can look at the site generic and also site dependent life cycle assessment when the effects are site dependent. And actually, Dr. Koenig already used this kind of graph. So we can look at the different stage and assess the probability and the consequence of those events. Okay. And then we can try to set up the MRV to reduce risk for storage. And those are the monitoring schemes. Okay, we can talk a little bit about the risk assessment here, which is not much beyond the description of Dr. Koenig. The identification of the CO2 leakage type. So we can identify the 4 types of emission, CO2 leakage. And we can analyze the potential emission pathways associated with these types of emissions. Okay. So for example, direct leakage. Direct leakage, injection well, oil and gas production well, and other abandoned well. Also well blowouts. Actually, that's the thing that most scare the public. And after the identification of the hazard, we can identify the risk of those hazards. So, for example, look at the overpressure in the reservoir due to CO2 injection and storage. For example, we look at the probability, the likelihood of occurrence, and the risk level. So here, the probability is quite low, based on literature search. But the risk is also low. Here, migration of CO2 into neighboring geological formations. The probability is quite high, but the risk is low. Okay, so we have the hazard, the event, the probability of event, and the consequence level of this event. Okay, we can skip this slide. And then finally, we have an indicator for CO2 leakage. So for example, this is just the example of the dose effect, the dose response relationship. But it is apparent that this relationship is still not clear. What kind of adverse effect will be when the concentration of CO2 is at different levels. So we have a lot of gaps in knowledge, like we still do not know much about the geological storage capacity effectiveness, legal and regulatory issues for a larger scale, and also global contribution of CCS to mitigate climate change, and the other system-wise issue. Okay, so here's the project-specific environmental impact assessment. I think I'm going to skip this and this slide. It's actually the story mentioned by Dr. Kerr about the the United States, the injection well class 6 regulations. Okay, so let me proceed to the final section of this presentation, which is a suggestion for future work. Because we are still at the early stage, so these are the opinions from the involved experts and authorities. The first one is to perform dynamic planning for CCS development, integrate existing CCS relevant projects and advance to the next stage, set up short-term and long-term goals, and then to build legal and regulatory framework to support CCS research, demonstration, and possible operation, to start demonstration projects, collect information related to monitoring and report of CO2 leakage, impact and health risks, and also to assess system-wide effects and pursue uncertainty management. And then finally, evaluate total social benefits and costs. And to place CO2 at its proper position, so it can be an asset, not a dangerous risk. Finally, we will incorporate the CCS into our national policies, like strategic plan for national spatial management, sustainable energy policy guideline, and a national waste management plan. Okay, so because the public acceptance for CCS development is a key, so these are the conclusions we collected from the consultation with the public. The first one is to apply strict international code and standards on regulating CCS projects, to communicate with the public by visualization of the existing project information collected from the CPC oil wells, supervise the CCS projects by locally such as engineers and scientists, to cooperate with international organizations and experts in CCS, engage the domestic experts to help with the projects, and finally to provide MRB, the worst scenario estimation and alarm system by the research group. I think that's all I'm going to present today. Thank you very much for your attention.